I'm stealing someone else's ideas. The Mint programming language. Imagine a world where with every line of code that you write, something happens that not only makes intuitive sense, but has a noticeable impact on the application that you're building. What would such a world look like? In this video, I will explore what an ideal future of UI programming could look like from my perspective. Then also as a bonus, we'll take a look at the Mint programming language, a language that I find really fascinating and to my knowledge has been underappreciated. And we'll see how it fares against my very objective list of criteria. And yeah, let's go. So the obvious options we have for building a UI are JavaScript and TypeScript. Why is that? Well, JavaScript is pretty much the only language that browsers speak, and TypeScript has become the industry standard for languages that get compiled down to JavaScript but actually contain some typing, some type information that we can use to prevent bugs, write documentation and the like, right? The first problem that I see with TypeScript, and actually a lot of other languages as well, is the lack of proper result types. So in TypeScript, when you perform an operation that could fail, you could either throw an error, or you could return null, or you could return undefined, or you could return false, or you could return an empty list, an empty array, or you could return an empty set, or you could return an empty string. These options are not ideal, because just the fact that we use an empty literal, if you will, or an empty object doesn't really give us much information. We don't really know that it's a failed result of some operation. Personally, I prefer a null because it's so explicit. But then it depends on the context where you are using the result of your function call, because you might be using the optional chaining operator, and depending on what you're using it for example, it might be a prop that you rather want to be undefined than null. So what makes sense to me is having an option type where you have either a value or whatever is the null option, and by extension a result type that gives you error information as well. And this ties into my next point, which is I would really love to have first level errors. So first level errors are an idea that I've been having for a while. I'm not sure if it exists out there in the wild. Maybe I'm just remembering something subconsciously without knowing. And I'm stealing someone else's ideas. But basically, the idea is that we don't have errors that are classes. We don't extend like the base class, but instead we have a different syntax to describe errors. And the reasoning for that is as follows. So typically when we throw an exception, we have two options. We either throw just some string that contains a random text that we define, or we create a custom error class. Neither of these options are great, because if you just have a string, you can't really do anything with it, because once you catch that error, you don't really know what you're dealing with. And creating an error class is a bit too difficult. It's like you don't really want to do it, and I don't like that. I really wish there was something that was easier to create, more straightforward, because errors don't really need to be classes. They don't need to have all of these methods. They don't need to have any inheritance. They don't need to have anything of the sort. Instead, errors should have some code that makes them unique and ideally globally unique. They might need some description, right? They don't have to, but we might want to have something that's human readable. In many cases, we don't even expect that error to be thrown ever. So it might not even make sense to have to write a description. We might be fine with just some code so that we can find the place where it originates from. And yeah, errors most often don't have any parameters, so we don't really need a constructor either. All we need is an error code and to throw that error code. That's it. I find it really sad that we don't have something like that, because we have a big problem with errors. Errors are so common that we want an intuitive interface for them. We want something that's easy to use. And my third gripe with TypeScript is that its enums are really weird, to say the least. We've heard the argument that enums don't really serve any purpose. And to be honest, I feel the same. I feel like They are nice syntax for something that should really be a first-class citizen of any language, but they really don't seem to be supported well. So one condition that I would set for any sort of enum implementation would be to allow for exhaustive checks. Every switch statement on an enum should always, well, solve all cases, right? So we should automatically get an error if we don't handle all possible cases of an enum, or if we don't add a default case. Another thing that I imagine a front-end language should have is built-in reactivity. So I'm not sure what the timeline is. I've seen it first with Svelte. It's also been part of Solid, I think, from the beginning. And we want to have this sort of reactivity in front ends. We want to have state that depends on other state and that is computed automatically, upon request at least. And we also want something that tracks whether it's been updated without having to recompute the state all the time. But also we want to have some flexibility over it. We want to be able to control which computations happen at which point, because it might differ from app to app, and it certainly can involve some performance problems if we don't do it right. And of course, we also might run into memory issues if we store too much state. All of those issues should have some solution. Once a component is no longer present, it should by default let all memory that it allocated get garbage collected, unless of course it's needed later again. And this sort of flexibility needs to be allowed. This ties into another idea, which is we should somehow have a way to track references. Surely we should be able to have control over the lifetime of variables within certain components or within subtrees of our component hierarchy. Naturally, we should be able to say that, okay, this subtree should own this piece of state and it should be available here, and then this other subtree is able to access that state, and then it just automatically figures out when to remove which state from the memory. So what was the list again? Exhaustive enum checks, first level error types, the Mint language really does have the potential to revolutionize front-end programming. As an invention, it's on par with light bulbs and fridges. Please welcome the Mint programming language. So what is Mint? Mint is a programming language designed specifically for UIs. So it's a tailor-made language that is made to handle all the challenges that are related to UI building. And so as you can tell here in the browser screen, we have a few interesting patterns that Mint provides for us. One of them is, for example, this state keyword, the component keyword, of course, the next keyword, which seems to be related to the state. And so it seems really exciting, and we'll take a closer look at it now to see how well it handles each of the points that we mentioned we want in a future programming language. Directly when we look at the documentation here, we can tell that Mint has a little bit of a gripe with JavaScript and its ecosystem, including NPM. So we'll see that this will be a problem, because using NPM is sort of a requirement for many front-end builders, and it looks like Mint does not support this very well. This is one of the main issues I think there is with it, and probably the main reason why it has not really been adopted, because this is an immediate red flag. How about we check out enums? One thing that seems quite cool is the ability to provide parameters. So you can actually define an enum variant that is sort of a generic, and it has a type parameter here of user, meaning that the logged in state probably requires a user object to be present. And then we can also use enums for result types by giving them parameters, and then that way the result type, the result enum, will actually be generic itself, meaning that we can create different types of results. And that is super useful for different kinds of results and for handling all the various edge cases that you can have in a front end. And you can even use plain strings for each of these cases if you so wish. So if you only have an a string that represents your error, you can just use strings here, which is probably not a good idea, but you know, you have the option at least. This is very interesting. We have a store keyword in Mint, and this store is a global container, meaning that we can access it from anywhere, and we'll get to that. But the way it works is you have a state keyword that you can use within the store in order to define values and variables that are probably not accessible from outside, so you can't change them from outside of the store. Yeah, so this confirms it. So the variable inside of the store, or the state variable counter here, can be changed using a next call where you provide the next value of the state, but you can only do so within the store itself. And that's beautiful. We do want this sort of isolation. This isolation is a good idea from my perspective. This is one of the main benefits of OOP, where you do want some isolation, and you get that through these sort of objects, or whatever you call them. Right here they are called stores, and so the store is a sort of class. And then how do you use those stores? So what you do is you have your component, and then you use the connect keyword to refer to a store within that component, and you also specify which parts of the store you want to expose or to use to be able to use them, which is here a state variable as well as a function that is able to change this state, because remember, we cannot change the state itself from outside of the store. Personally, I think we don't always have the right use case to be able to extract a state variable, because it often cannot be separated that well from specific UI behaviors. For example, animations often need direct access to state variables and their current value in order to calculate the current width of something, or whatever it is, rotation, transforms, and so on. So stores, good idea in general, maybe not the best abstraction for all kinds of state. However, I do think overall this is a great idea, and depending on how it's implemented, it might actually be something that is worthwhile to be using in the long term. It just depends on the interfaces between stores and how well you can invalidate certain stores and how reactive it actually is. So we'll take a look at reactivity here. How is reactivity implemented? Let's take a closer look right now. Alright, taking a look at the reactivity, we do have computed properties, as they're called here, and I assume this is implemented with signals or something similar. Getters, we do have them in JavaScript as well, and they're essentially functions that we can use to define other properties that we might need. So it's sort of a selector, if you will, or a piece of state that depends on other pieces of state. In this case, we have a getter called text, and we use the name property of the component to be able to define a new property that depends on that name property. What I think is interesting about computed properties is that it's sort of a replacement for what we have as use memo in React, and of course we have computed properties also in other frameworks like Angular and Ember.js. So in general, I think the idea is that we want a way to define state based on other state that is super intuitive. And computed properties are that, right? They are simply functions that allow us to define how to calculate a new piece of state if the original piece of state or the set of dependencies have changed. And again, a beautiful abstraction here. I wish that more languages had this. I wish that there was better support for this within TypeScript. We do have getters, but they are not connected directly to components. We have to always perform equality checks or do some weird optimizations in order to make sure that we always have the latest value that we need, right? And we can at least recognize how you could build something like this. And then I also think the internal state page here is super interesting. So you can have states that are part of components as well. And then you basically define functions that change this state, and you call them. This is very similar to what we also do in React, where we do have functions that we create and then we call them in some event handler or wherever. We can also define them in hooks, and return those functions from those hooks, call the hooks, and then call those functions wherever we need to in event handlers or other lifecycle functions wherever they may be needed. So I assume that the next keyword and the state keyword are helpful in optimizing the updates of components so that it's well defined when a component needs to be updated, and that's probably the reasoning behind it. I can't really confirm this thought yet, but I would be very surprised if it wasn't the case. Or at least the basics are set for that to be possible eventually. Here's another nice finding. So apparently Mint supports the pipe operator, or some version of it. So you can see this kind of usage here. So Mint has been designed in a way that it doesn't cause runtime errors if you do not use JavaScript interoperability. If you want to inline your JavaScript, you can do so in the way that's described here. So you can use backticks to call custom JavaScript. And you could probably minify some JavaScript and put it in there. I'm not sure if that's the recommended way to do things if you want to use some NPM package or so. But overall, it's great that it exists, and you have to expect there to be the possibility of runtime errors as soon as you use this kind of JavaScript. And it's actually quite the interesting concept that you will not get runtime errors if you do not use this. So if we take a look at all the conditions that we have, result and object types, so we do have some version of this with generic enums. So I'm not sure how well this fares, but it's a concept and it's one kind of implementation of this concept. Why not? I'll give this a yes. Thank you for building this. First class errors, we don't have this. We have really beautiful error messages actually with Mint. However, so it doesn't have errors as first class primitives of the language. However, it does offer the option of creating a result type that allows us to specify an error type. It's not perfect in my eyes, however, it's a massive improvement. Really nice. Exhaustive enum checks, we do have this, so let me show you in just a second. If you look at the test that Mint has for the case statement, then you will see that it actually has an error for if you don't handle all cases of an enum. This is exactly what I wished for, and I'm super happy to see this here. Let me know what you think about it, because I think it's really cool. So here we have the enum A, we have variants B, C, and D, and in this case statement, let me go a bit closer. So we have this enum A and variants B, C, and D, and then in this case statement we only handle B and C, and it'll throw us an error and say, hey, look, you're not handling the D variant. What more could we wish for, right? Perfect. I love it. Built-in reactivity, I would say yes, this is sort of part of it. Yes, we have states and we have the possibility of creating new computed properties, and those computed properties can use state variables. Those state variables are explicitly defined, they are typed, and so there is a first-class concept of state management and states and updating states with the next keyword, as well as connecting stores to components. So this is all really super nice. We'll have to see how this fares in practice, but just looking at it, I'm quite amazed at how well it seems to support this sort of reactivity. Great work finding this abstraction. Let's move on. Lifetimes, I don't think this is a concept that's supported here. We have lifecycle hooks that look similar to the previous lifecycle hooks that we had in React, which is we have component, will, mount, and these sorts of functions that we can define and use. However, we don't really have anything that allows us to control the lifetime of a store. Maybe it's done automatically, depending on whether a store has been connected to any component, and if it's not, then maybe the reference gets removed and it gets garbage collected automatically. I'm not sure how well that's implemented. It might be possible, but on the surface I can't seem to find any of this. Maybe it's just implemented in such a good way that it's fine. But I can't see any direct reference to this. I can't see any mention in the documentation, so I'll just count this as a no. However, in general, I think that the reactivity concept here may be quite thorough, and so we'll have to look at how it fares in production. Again, it's not for me to decide based on a surface level look at this language. Now, I talked about reactive state and that reactivity should be built into front ends. And if you're interested in state management and what my opinions on state management are, how you could improve it, and how we could reconsider the way we think about it, be sure to check out this video. I've linked it here. And yeah, thank you so much for tuning in. Hit the like button. See you next time.